Hello everyone, I'm Moinak Ghoshal from UV Lab. Today I'm going to talk about the wireless network standard 802.11ad used in recent smartphones. The main motivation behind this work is that today a class of smartphone applications like virtual reality, augmented reality, or Ultra HD video streaming services require a high network bandwidth of Gbps speed. 802.11ad is a very good candidate for that. Let us see some of the features of 802.11ad. The unlicensed 14 GHz spectrum around the 60 GHz band and the 2 GHz channel width gives 1180 theoretical data rates up to 6.7 Gbps. This is a multifold increase over its competitors in the 5 GHz spectrum, the legacy Wi-Fi 802.11ac, and the state-of-the-art 802.11ax. But 802.11ad has its own challenges. It is very much susceptible to blockage and mobility. Until recently, there were no commercially available phones that supported 802.11ad. The power consumption of 11ad on a phone was unknown, and people worried if the high data rates would mean a huge increase in power. In this work, we, for the first time, do a thorough and comparative study of power and performance characteristics of 11ad in smartphones against 11ac and 11ax. We also report the first study of power saving policies in 11ad, which is more aggressive and complex than 11ac or 11ax. We extensively study the performance and energy impact of the three technologies on the real-world application under realistic user mobility patterns. If we look into this table, we can see that 802.11ad is the only technology which achieves Gbps throughput. This is one of the primary requirements of the applications that I had mentioned before. If we look at the active power consumption, we can see that 802.11ad has a higher receive power compared to its transmit power. This is just the opposite for 802.11ac or 802.11ax. Interestingly, the transmit power for 11ad is the lowest among all the three technologies. We also notice that due to aggressive power saving policies in 11ad, the low data rates have non-monotonic power. Now let us look into the power saving policies in 11ad. The PSM timeout, it is the time between a transmit or a receive activity done on the phone and the radio going to sleep. For 11ac, it is a fixed value at 200 ms always, but for 11ad, it is a complex set of policies based on inter-packet arrival time. The radio on the phone somehow learns the traffic pattern and sets an appropriate PSM timeout value. For example, for a high data rate having very low packet inter-arrival time, the PSM timeout value is practically zero. Let us look into the impact on real-world applications of the three technologies. For Ultra HD video streaming, it requires a data rate of 1.33 Gbps. 802.11ad is a clear winner here. For static scenarios, there are no stalls at all, and for motion scenarios, there are very few stalls, which can be attributed to the fact that high data rates allow buffering of frames. But the energy for 11ad here is slightly higher than 11ac or 11ax. Next, for browsing experiments, we use PLT or page load time, which is a good indicator of how a network is performing. 802.11ax has the shortest page load time. Ideally, 802.11ad should have the shortest page load time, but this is not the case due to PSM. Surprisingly, when we turn off the PSM, we see for 11ad, it has a shorter page load time and a very low energy. For virtual reality, 802.11ad does not meet the application's demands of 60 FPS. Interestingly, for 8K resolution, which is a hypothetical situation and is not available in current phones available in the market, 11ad performs much better than 11ac or 11ax by a margin of 60 to 65%. And this is very promising. But the beamforming in 11ad increases the energy consumption. Finally, let us look into Miracast, which is an uplink intensive application compared to the other three apps I had discussed. So for Miracast, 802.11ad is the only technology that meets the application's demands and also is the most energy efficient. To summarize, we can say that 802.11ad truly offers Gbps rates, provides the best performance, at low energy cost. In contrast, the aggressive power saving policies sometimes have an adverse effect on the performance and energy of 1180. Thank you.